Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 16, Liquids and Solids, Part 3. Here are our objectives for today's video. Pause here. You do not need to draw the picture. So we've discussed all the different sorts of forces that go on in many different molecules, but we haven't really talked about covalent network solids, at least this year. So these are gigantic molecules that are purely covalently bonded, diamond being a really great example of it. Silicon also can form covalent network solids. So really anything group 4, but carbon and silicon are really the most common. So these molecules are absolutely astronomical in size compared to, say, CO2. And for that reason, they've got extremely high intermolecular forces. And when I say extremely high intermolecular forces, I am specifically referring to London dispersion forces. So when you have sufficiently high molar mass, London dispersion forces can be extremely high. So that's why these sort of compounds are really elements rather, these sort of molecules are extremely hard and also have extremely high boiling points and melting points. Pause here. All right, so I'm just going to work through this. I've got 4 different molecules and I'm going to match it with the description. So CSCl, that is ionic. So that is why of all of the choices, the first one, the fact that I've got positive and negative ions, that is going to be the best description. Gold is a metal, so I'm going to look about something for an electron C, and that is the second one. CO2 and methane. So these two are going to be kind of similar because both of them are nonpolar. So it's really a matter of which one is the third description and which one is the fourth description. I'm completely throwing out this one right here because of the fact that I don't see any sort of what would be a macromolecule like C6H12O6. So I'm going to assume that that is the one description that doesn't really fit anything. So one says that it has multiple pi bonds. That is describing carbon dioxide. And then strong single covalent bonds, that's what describing CH4. Weak intermolecular forces, that is also describing it, hence this being methane. This was taken from the 1998 AP Chemistry exam. Pause here. So this is just an overall comparison of these different types of solids. We've talked about all of them at some point in time, but I just made this table just to compare them compared to one another. But you should have seen all of these. Ionic we saw at the beginning of your sophomore year. Whereas atomic molecular, they typically are pretty similar depending on the type of molecule. Covalent network is what we just talked about. We talked about properties of metals your sophomore year as well. Pause here. You don't need to draw the picture unless you prefer to. Right, so phase diagrams, they show how the state of matter depends on temperature and pressure, and that's why pressure cookers work. It actually increases the boiling point of water if you have an Instant Pot or a run-of-the-mill pressure cooker. Also, these can explain why some things sublime under certain conditions and some things will melt under certain conditions. Every single substance can theoretically have a phase diagram associated with it, and then one typically exists if somebody has taken the time to make one. Pause here. All right, so notice in the slide prior, and I'll go back for just a moment, the solid is on the left, the gas is on the right, and then the liquid is up here. So that is just showing where everything is. That's usually going to be the case. If it's not that way, it should be labeled. So this is asking for the equilibrium between solid and liquid phases. So I'm looking for that, what is right at that point. And I see that only one thing is dividing it, and that is C. There's one more point that I want to add here, which is, I'll get rid of that strike through. So at the point where liquid, solid, and gas meet, this is called the triple point, and you should include that in your notes. And at this point, which means that at this temperature and pressure, and only at that temperature and pressure, all 3 phases of matter coexist. rates, but you have to be exactly at the temperature and pressure, which is why this is not commonly observed. Right, here are the additional practice problems and suggested reading for today's video. Thank you so much for watching and have a great night.